Hey guys, welcome to Objective 2.1, Creating Types. Today's objectives cover how to choose what type to create, how to create your type so it could be easily used, and how to extend existing types with new capabilities. So overall, mainly this chapter or this objectives is about understanding what tools you have in your toolkit. Um, Basically, when we're writing applications in an object-oriented programming language, creating and using types is a really important feature. So this chapter is really just dedicated to showing you how to properly pick what options you have, because there's all these available options for you, right? We can create generic types, we can create value types, reference types, class structs. We can do all these things, but when is the best time to do each one of them? And that's what this chapter is about. This chapter or this objective, this objective isn't about teaching you how to make a class or teaching you how to make a structure. It's teaching you when should I use a structure or when should I use a class. Also, like, it's not teaching you how to make a function, but we'll go over like what are good practices when creating functions, like what should a function consist of, what should the name look like, and things like that. So if you're watching this video to learn how to create types, although we will do some of that, like creating an enum, that would be our first thing. Ultimately, this is about showing you tools and then showing you when to use each tool. So to get started, let's just talk about really briefly and quickly the three basic types that we can use inside of C Sharp. There's three different main types. We have value types, reference types, and pointer types. So value types and reference types. I am going to briefly go over them and explain the differences because it's part of this chapter. But I also separately made in the advanced C# category, I have a video on value types versus reference types that I go into, not full detail, but I go into a little bit more detail than I'm going to go here, talking about what's the difference between value types and reference types, and I showed a little bit with memory and things like that. So we'll get into value types and reference types a little bit in this. But there's also a third type, and that's our pointer types. C# does support pointer types. Although if you want to use pointers like hardcore pointers, you have to mark your code unsafe, and you also have to mark the compiler unsafe. There's two different steps that you need to do with that. But you can use pointer types, although it's not completely like using pointers in like C++. C# does still support pointers. Although I like to think of references or reference types kind of like managed pointers. Like behind the scenes, reference types are using pointers, but it does it in a managed and a controlled way. And we also have garbage collection in C#, so we don't have to worry about releasing our dynamic memory when we're dealing with that kind of stuff. Alright, so the first thing I want to get into, this is what the book starts with, is creating an enum. They actually show you how to create one because they're assuming that maybe most people don't use enums, and they just want to show you what an enum is. Now, an enum is a value type. It's a value type. I don't know what the word for it is, but an enum is a value type, and an enum is simply a group of constant variables. Simply using enums just help the readability and the maintainability of your code. It's a simple value type that allows you to group a group of constant variables, put it into a nice type. It's its own type, and then you could use that type however you want. So we'll go ahead and create an enum, a really basic enum. We're going to do one that talks about the days of the week, so Saturday, Sunday to Friday. And then we'll talk about how we display the values of that really quickly, and then we'll move on to value types versus reference types. So this is an example of a value type, however. Alright, so to create our enum, we're going to go outside of the function, because this is considered a type, we're going to use the enum keyword. Now, we also can specify our access modifier. We're going to say enum, and we're going to call it days. And then we're going to set up our block like this. Now, the book puts a colon right here and says byte. And by simply doing that, that just specifies the default values of what's going to be stored inside of your enum constants. And I'll show what I mean by that. But if you leave it empty, I think it just defaults to an integer. So let's go ahead and now inside of our enum, we're going to say, okay, Saturday, we're making a constant variable for Saturday. And we're going to say Saturday is equal to 1. And now, after we did that, we can just go Sunday, Monday, Tuesday, Wednesday, Thursday, and Friday. Now, notice how when we start a Saturday off as 1, enums have the special ability that they start incrementing that starting value and add the next value to each of the constant variables. So Sunday will be 2, Monday will be 3, and so on, just by specifying a 1 right there. If I went equals 5 right here on Tuesday, Wednesday would then start at 6, and then it goes 7, 8, if I did that. But if I don't specify any of them, it starts like that. But I specified Saturday, so it all starts at 1. So it'll go 1 to whatever. So it'll go 1, 2, 3, 4, 5, 6, 7. Now, so we have our basic enum set up, and we can see that an enum is a type because of the color. Look, it's like that light blue color, and classes also have that. Cause like we all know that class is a type. An enum is also a type. It's more specifically a value type, and because we can see that color right there. So now we have our enum made, we can access the values of our enum by going days dot. And we can see the values inside of our enum. We have Friday to Wednesday as right here. Now, like I said, an enum is a group of constant values, so we can access these constant values by just going days dot Thursday, and then we get that constant value. However, we need to do something before that to make sure that happens. But on a side note, before I get into that, another thing that's cool about enums are that enums, like I said, it's a value type. So it's a type, and we can create variables of any type. So I can go day and say my day, and my days equals to days dot, let's say, Friday. So let's say Friday is my favorite day. So I made a variable of type days, and now it's equal to days dot Friday. So I can use an enum to create variables because it's a data type, it's a value type. Now, if I wanted to display the value of, let's say, my day to the console, I could go console.writeLine and say my day, but when I do this and run this, we see the word Friday show up. So we're actually getting the name of the constant variable rather than the actual value that the variable is holding. Now, in order to get the value, we need to cast it to the data type that we want. So if I say, okay, cast this to an integer now, cast my day, which is a constant variable, instead of getting the text version of it now, I want to cast it and get the actual value that the variable is holding. So by doing this now and casting it, now I'll get the value it's holding, which is that 7. So as you can see, it incremented by 1 each time, and Friday is holding 7. Alright, and that's pretty much the basics of enum. That's all I'm going to go into with it. An enum is a group of constants. You set the values and the auto increments. You could do different values for each one, though. I mean, I could specify a different value for each one of my constant variables in here if I really wanted to. Enums are data types, so you can create variables of them like we did. And to display and actually get the value of whatever is stored into that, we have to cast it to our selected type, which by default is an integer. So that's the basics with enums. So I don't think the rest of the chapter really goes into explaining and creating types like this. It might a little bit, but like I said, the main purpose of this objective is to understand when I would want to use enums and when I would want to use other things. Like I said, if we have a bunch of constant variables and things, the reason why we would want to use an enum is because enums improve the readability and maintainability of your code. So it's a cleaner way than having a bunch of constant variables. It's easier to maintain. It's easier to understand, right? If I go days dot, I understand that it lists all of the days and things like that. So that's the reason why I'd want to use an enum. Okay, so now that we got enums out of the way, now we can start getting into some more fun things. So the first thing we're going to now get into is what are value types and what are reference types. Now you may know what these are, but you may not necessarily know how they work behind the scenes, and this is what this is really about. So first things first, what are some examples of some value types and what are some examples of some reference types? So the most basic example that we just saw right here, an enum, is an example of a value type. We also have a struct or a structure. Those are examples of value types, and we've been using those a while in all our lessons. For instance, an integer, as you can see, it says struct, system.int32. So an integer is a structure, doubles are structures, all these things are structures, as you can see. Struct, bool, structure, and now this is integer. I wonder what it says for this. Yeah, look. So strings, although we use strings like they are value types, strings are actually reference types, which we'll get into a little bit. As you can see, it says class for string, rather than a structure. A string is a class, and that just led me to the next part. Reference types are an example of a reference types are classes. That's the most common type of reference type. Classes. So whenever we create classes, we're creating reference types, and whenever we create structures, we're creating value types. So those are the basic two examples. Now we need to understand what are the differences between a value type and a reference type. So before I go into a structure and a class, because those are the first two things that we're going to deal with, overall, let's talk about the overall memory differences between a value type and a reference type. So there's a couple things. Value types, you can think of value types holding their memory or their data for whatever value type it is in the same location or together. You can think of it logically together. So if I have an integer called x, logically just think of it as that the value of x, let's say it's 5, is attached to that x. You could think of them as a pair. They go together and they're stuck together and they can't leave each other. So you could think of them as one group. You could think of a value type as something that is contained completely together. Whereas with a reference type, you can think of them differently. You can think of the variable. So you can think of the variable of a value type or a reference type and the actual data as two different locations. So like I said, with an integer, which is a value type, int x equals 5, you could think of the variable, which is this int x. My x is my variable, and my 5 is my data. So you can think of the x and the 5 being together. They're stuck together, and they're right next to each other. Think of it that way. Whereas a reference type, you could think of the actual reference. So for instance, a reference type class that we've maybe used is the random class. So the actual R is my reference, but the data is this new random class. You can think of this as being two separate locations. The actual variable is holding the reference to the actual data. Now I'm going to show you in Paint what this looks like really quickly, because like I said, I made a video for this, so I just want to really quickly go over this. So here's Paint. I'm going to quickly illustrate the two differences between this. So first, on the left side, I'm going to do a value type. So my declaration is going to be int x equals 5, right over here. And on the right side, I'm going to do a reference type, and my declaration is going to be random r equals new random. So these are my two different types. Now, what do these look like behind the scenes is what I'm going to show you. This is not actually what memory looks like. If you want to see that, look at my other video. But this is what they look like physically, sort of, behind the scenes. So I'm going to draw a rectangle for both of them to start off with. So on the left-hand side, let's also draw a line. So the top portion is going to be the variable, and the bottom portion is going to be the actual data. So this is our setup. On the top part of int x equals 5, the actual variable is going to be x, and the actual data, what is stored in the data portion of it, is going to be 5. So that's what that looks like behind the scenes. We have the actual variable x and the data. You can think of this portion. Where's my brushes? You could think of this portion right here as the data portion. Whatever is inside of that is the data of the variable. So now for the reference type, on the top we get an R, because that's, oops, let me change the color. On the top we get an R because R is my variable, just like X was. But for the data, it's a little bit different because this is called dynamic memory, and I'll talk about this in a second. With the reference type, inside the data portion is not going to be a value or some kind of data. It's going to be actually a address, a memory address, or you can think of it as a pointer. So what happens in reality is with a reference type, I get this separate data location down here. This down here contains the information about the random class. So I don't know what they have, but this is, so this right here, let me just write it. This is the data, or the data of the random class. So this is the data of random class down here. So when I go random r equals new random, what's really happening is I'm getting this picture. So this is the difference. Like I said, the value type has its data attached to it. Int x equals 5. The 5 is attached to it in the same block. Whereas a reference type, the data is in a separate location and the block is just pointing to it. Now there is the reason why this happens like this, and the benefits of this is because I can have other reference types or other variables pointing to the same memory, and then they're pretty much the same variable. So for instance, if I had another declaration like this, if I said random x equals r, like what would that picture look like? And that picture would look like something like this. We would get this picture, we would get the line, we would get the x, that's the name of my variable right here, and then we would get this picture. So as you can see, we didn't call new here, so we didn't get any new dynamic memory. You can think of this. This is our dynamic memory right there, which I'll talk about in a second. We didn't get any new dynamic memory, so pretty much all that's happening is we're pointing our new variable into the same memory that this variable has. So now they have the same exact memory location. So any changes that I made to this x, it would affect this r, because they're pointing at the same memory. Now, for the same example with my integer, if I did a new integer like this, so let's make my memory, my line. If I did a statement like this, let's say int y equals x, what would that look like in memory? Well, that would look like this. So my variable name is y, that goes there, but my data, instead of pointing to it, or because there's no extra memory, all that happens is it dumps whatever value is in the 5 into there. So now the 5 just gets dumped into there. So now with the value type, it pretty much copied the value. Each of them had their own 5 now. Each of them have their own data, whereas with reference types, they point to the same data. So value types, when you pass by value, it makes a copy. If you pass by reference, you're actually passing the reference. And this applies to function calls also. But like I said, I don't want to go into this too much because that's not really exactly what the chapter is about. The chapter is about just what's the difference between value types and reference types. So this is the basic difference, right? The data for a reference type is stored in dynamic memory, whereas the data for a value type is stored in different memory. So let's really quickly go into a little bit of memory. So in memory, I don't think this chapter really goes over this, but in memory, there's two types of memory. There's stack memory and there's heap memory. All value types, if they're defined inside of main, are pushed onto the stack. And the stack memory is managed by us when variables go out of scope and things like that. Depending on what happens, things get pushed and popped off of the stack. So the stack memory, which is where value types go, is managed for us. But also the heap memory. Heap memory is where reference type variables go. So the actual reference, so right here, this actual random rx equals r, something like that, that would go onto the stack. But the actual data, so the data portion down here, which is right here, this data portion, that would go onto the heap, because that's dynamic memory, and that's managed by the Common Language Runtime's garbage collector. That's what that's managed by. But if you came from a programming language like C++, dynamic memory in C++ is not managed by a garbage collector. There is no garbage collector. So you actually have to, when you create dynamic memory in C++, you have to release that dynamic memory as well, or you can get memory leaks. So this is the basics of value types and reference types. Like I said, I have a video dedicated to just this, so if you want to go take a look at that and maybe you'll get a better understanding. I pretty much use the same examples as this, but I go into it a little bit more in detail. So this is the basics of value types versus reference types. So let's get back to the programming now. So now that we went over the difference between value types and reference types, now we can talk about, what are the benefits of using structs? What are the benefits of using classes? When do I use each? Because that's what this lesson is about, like I said. So, like I said, a structure is a value type, so that its data is stored how you saw in those pictures. Now, when would I want to use a structure? What are a good times to use structures? And you want to use a structure if your object is small. That's the first thing. So if you have a small object, it's a good time to use it. You want to use it if the object is logically immutable. What that means is that if your object doesn't have to actually be physically immutable, which means that it doesn't change. Logically immutable means that that it logically won't change. So a perfect example of this in the book shows is a point that has an x and a y coordinate. Most of the time, those logically won't ever change because you need each point. But you could have lots of points, but logically, the x and y value of a point does not change. And the third reason why you would want to use a structure is that there are a lot of them. So, like for instance, a point. If you have a grid, points for x and y, you could have a lot of points. So that's a good time to use a structure. So I already made the example of the structure right here. So this is an example of what the book gives of a structure for a point. It's pretty basic. It just has, this is how you define a structure if you didn't know, with the struct keyword instead of the class keyword. As you can see, the point is that light blue, so it's a type. More specifically, it's a value type. It contains two public fields, which you could actually, it doesn't really matter. It contains two public fields, x and y, and we have a constructor, which we'll talk about a little bit more, what the benefits of using a constructor and things like that are. That takes in an integer, 0.1 and 0.2, that are passed in, and they fill my x and my y for my structure. So this is just an example of the basic structure. Okay, so we'll get into classes because in a little bit, because I want to talk about blueprints and things like that with classes. So let's stay with structures a little bit. We're not really staying with structures. We're actually kind of with classes also. But let's talk about adding behaviors to our things. Now, what are the benefits of this? How are the proper ways of creating functions or behaviors and things like that? So first things first is when we want to create a behavior or create a function for our own personal types, there's four things that we should consider when we're creating them. And I'm taking this right from the book. The first thing you want to consider is the name of the method and we'll talk about this in a little bit more, but the name of the method is important because you want the person who's using your code, or possibly you, maybe in a later date, you want to make sure that you understand what the function's doing by just the name. So like I said, you want to just be able to look at the name of a function and be able to say, okay, I know exactly everything that's going to happen inside this function. That's an important thing to note because in object-oriented programming, you don't want to create functions that do lots of things. You want to separate and break things into functions or into separate functions, and the name that the function has implies exactly everything that's going to go on in that function. So that's the first thing. You want to decide what data should be passed to your function. So that's another important thing, which we'll talk about in a little bit more detail after, because you want to make sure what is the most efficient way that take in parameters. Like, do I absolutely need this parameter? Or am I passing in a class where I don't have to be? I could be doing something maybe a little bit easier that I'm wasting passing something in. So we'll get to that. Decide which data you want to return to the caller. So this is important. You want to make sure that the caller and both you understand what data is going to be getting returned from the function. Should I be returning void? Should I be returning integer? What is the best way of doing it? Should I, if I add them together, should I return the value, let the caller handle that? Or should I maybe print out or do something with the results inside the function? It depends what you're doing. And the last thing is decide on the visibility of your method. So is my method going to be a private function that only my class can use? Is it going to be a public one? Should everyone be able to use this? So those are some decisions that you want to be able to make sure that you're doing properly. So this is a question from the book. If I was following these guidelines and things like that, if I wanted to create a calculator, let's say class, it could be anything, doesn't really matter, that needs to be able to add two numbers together, what would the method look like? So let's go ahead and create what the book did, and I'll write it really quickly, and then we'll talk about it a little bit. So let's go ahead and create a class, which, like I said, we'll get into classes more, not necessarily how we build classes, but because, like I said, this is not about building classes. We'll talk about, what blueprints are and how they work, maybe on a little bit more of a deeper level. So let's add a class. Let's call it calculator. So the thing said, following the steps that it just gave us, what is the best way, or what should the method signature look like following what we just did? So I'm going to write out the function, and then I'm going to go over the steps. Okay, that's it. So let's go through the steps and see if this is a proper way and if this is a good way to have defined this function. So the first step was choose a name for your method. So our name. Does our name properly describe what our function is going to do? So it says add. By the caller of this function knows specifically what the function is going to do. It knows that all it's going to do is add two numbers together. That's it. The caller should be confident that the add function is not going to be doing other things like maybe displaying the value. Because maybe if we wanted to display the value, it would be add and display. Or maybe the function is not doing some other calls to other functions. It's not doing code that are accessing databases. I don't know. It's only doing what the name of it describes. So when reading the method name of a class, I'm just reading this out of the book. Okay, here it says, yeah. Well, it says the name add clearly states what the method does. So that's what I've been saying. It's important to have your function name do exactly what it says. So the second thing, decide which data should be passed to your function or to your method. So we're passing in an int x and an int y. That's perfect in this. What we called them and everything. So we said x and y. So that represents two numbers. Those are good names also for the caller. So the caller came in and said, it was using his IntelliSense said add, and then it looked at the parameters x and y. Well, those are classic mathematical variables, so it makes sense that we're passing in an x and a y number. We could maybe name them other things, but these are fairly decent names, and the caller can understand what is being passed in. The third thing is decide which data you want to return to the caller. So we specified a return type of integer because we were returning the value of x and y added together. That's perfect. We're adding the values and returning it back to caller. That's a perfect return type. And then decide on the visibility. So do we want our function to be visible by all people or no, or just the private people? And we chose public, which is perfect. We want everyone to be able to add two numbers together. So we don't want it to be private. This is a public function that anyone can use. So following those 4 steps, you can create proper functions, and that's what we did for here, and that's what it looks like. So this is listing 2-4, creating a method. Okay, so now let's stay with the concept of parameters a little bit more, and let's talk about what types of parameters should we pass in, and what are the best ways to do it. So in listing 2-5 and 2-6, this is what it goes over, and it says, this is a good quote, it says, when deciding on which arguments to take, it's important to think about what you will do with the data. That's really important. You want to make sure the data that's coming in that you're passing in is exactly what you want. Like, there's no point to take extra data. So in the 2 functions, it's saying, which function should we choose? So the first one takes in, it's saying both functions are calculating the distance to an address. That's what we want to do. Now, the first one is taking in a customer, which has an address attached to it. But first, when that customer comes in, we'll have to, access the address of the customer, which is an extra step in extra code that we don't need. And it says that, some difficult calculation that uses customer.address. That's one way. But the other function does the same exact thing, and it says calculate distance to address, and that's just taking in the address. So now it's just handling the address, and you don't have to worry about the actual customer. So what will happen is the caller, whoever is calling the function, would either go calculate distance to and pass in the whole customer, or calculate distance to and just pass in customer.address. So then by doing customer.address, on the function side, we have the easier part when we could just access the address just how it is. We don't have to worry about the customer at all. So that's what pretty much that goes over. And it's just explaining that, as parameters, take in what you absolutely need. If you need an address, take in the address. Don't take in the whole customer that, although may have the address, just take in what you need. So that's listing 2-6. Okay, so working with data inside of classes, no matter, whether the data is coming in as a parameter or we have fields or whatever we're doing, we have an internal array. There is a few tools that I want to quickly go over. I'm not going to write the code for it before we start talking about classes. A few tools that we can use and when we should use them. So the first tool is using named and optional arguments. So these are fairly new features, and these are just 2 tools that we can use. And when should we use them? What are the proper ways? And the book doesn't really say it that much, but I'll try to explain it the best I can. So a named parameter or named argument is one that allows you to specify which parameter you want to call. So you don't have to, by default, you have to call parameters in order, right? So depending on how the method has it. But with using named parameters or named arguments, you can say which one I want to execute. So I can say I want to execute the third argument and just pass that one in. Now, this goes hand in hand with optional arguments because depending on which ones you pass in, the default values can kick in with optional. So optional arguments is that you can supply a default value for an argument. So if the caller does not actually pass in a value for that argument, you can specify a default value that if it does not get one, it will use the default value instead. So this allows you to only, if you have 3 arguments and one of them has a default value, you only have to mandatory pass in 2, because the third one, the default value will kick in if it has to. So, the benefits of using this is just really just ease of use, right? So if you're writing things that if you don't necessarily need all the data, some can be a default value, like an integer could be a 0 if it really has to, or maybe a 10, whatever it is, and you don't really necessarily need that information. You can specify that default value, and it just makes your life easier. So that's one benefit of that. Another tool that we can use is an indexer. I actually have a video on the advanced C# just for indexers also if you want to see that. But if we have a class or some kind of type, and in the background of it, it's using an internal array to manage its data, some kind of data structure stuff, or maybe it's using, I don't know, it's using some kind of data in the code behind, or in the behind code file. You can use an indexer, and by implementing an indexer, that allows you to access the elements or access data inside that type using the index operator. The index operator is that operator that arrays have, that you can access the index using those square brackets. That's the index operator. So you can apply that to your own custom data types for to make it easier to access data. So, if you want the user to be able to iterate over all the collection or all information in your type, you could implement an indexer, and then the user can write a for loop and go over it, or access random elements. By implementing that indexer, you kind of implement random access to whatever you're doing. So that's another tool that you can use in your toolbox, an indexer. We also have another tool, is the static, marking things static. So by marking things static in our types, that allows them to be type wide, right? So if we have a class, right, each class, we'll talk about blueprints here in a second, each class gets its own data. But if you mark things static, a static thing remains static to all the types. So if you have 100 classes or 100 objects that you created, each of them, if they have a static variable, will use that same static variable rather than creating their own data every single time. So static variables apply to all the instances of a class. So that's another tool. So those are just 3 tools that we can use when we're working with data. Okay. So now that we got all that out of the way, now we're going to start talking about blueprints a little bit and how the framework of a class. The first thing that we're talking about is when we're creating new objects and we use that new keyword is doing a bunch of things. One thing it's doing is creating new memory. That's creating that dynamic memory for the heap. That's what it's doing. But it's also calling the object's constructor. And the constructor, what does the constructor do? So there's 2 main things that we use a constructor for. The first thing we use a constructor for is to initialize the type with data. So whatever data we're passing in to initialize it, and to also run some initialization code. So for initializing other types that the class is going to be using and other things like that. So, but ultimately, the job of the constructor is to start up the class and prepare it for the use of the class. It gets everything ready, and that's the constructor's job, is just to get everything ready for the class to be used, whether that's initializing other data in the class and other things like that. So now that we have that, let's talk about briefly when people say blueprints, because this terminology of blueprint is used so much in programming books. So you can think of, when you create a class definition, you can think of that being a blueprint. Right now, let me relate where this blueprint came from. Let's say we were building a house, and we wanted to build that house. We would create a blueprint for that house. And then we would build a house based off that blueprint. Now, let's say we wanted to create the same exact house right next to it. Would we create another blueprint to create the same exact house? Or would we use the existing blueprint and just use that to create the same exact house? Because they are the same houses, we can use the same one blueprint. There's no need to create another blueprint. So that's where this idea came from, is that our class is our blueprint, and we can create many instances of that class by using the same blueprint, by using the same class definition. So by using that same one blueprint, we can create hundreds of thousands of instances of that by using that one blueprint. So the class definition is a blueprint. So that's what we can think of it as. Now, a couple of things of proper uses of designing classes are, and I found this pretty interesting. When we're designing a class, there's a principle that we can follow to make our classes meaningful and really reliable. And there's this one paragraph that says these principles that I'm going to kind of go over mean that code shouldn't depend on other code when it's not absolutely necessary. This enables you to make changes to code without worrying that your changes will ripple through code and affect other subsystems. And that's a really important little statement right there, right? Your code, when you create classes and objects, you don't want your classes to rely on other things, whereas if those other things change, you could negatively affect your classes. You want yours to really be a standalone thing. You want everything to be encapsulated in it and be able to stand on its own and be able to function by itself without having to worry about changes rippling through your code and affecting other subsystems. And there's this little acronym for design principles. It's called SOLID. And I found this really interesting, and it's all really true. And you can look at the book and read them. It's solid. Each of the words stand for something. And they all explain something that, when you're building a class, you could follow these guidelines and you'll make a nice class. And I think it's pretty cool. So go ahead and take a look at that. It's on page 100 of the textbook on table 2-1. It's pretty interesting. Just take a look at the descriptions of each, and that will probably help you build better classes. Okay, so along with types, we get more tools for our toolbox. The next tool that I'm going to talk about is using generic types. A generic type allows us. Generic types have a couple of cool things about it. A generic type, when we create, we can make a structure, we can make a class, we can make a bunch of things generic. And by making them generic, it allows us to pass in the data types or that the thing is going to use at runtime rather than, at design time. So we don't have to design the class around. Let's say we were creating some kind of data structure that is holding a bunch of information. In the code behind it, if we made it based around integers, if they wanted to store strings, we would have to make a whole new class. Using generics, we can supply a generic class that they can pass in either a string or an integer, and it will work perfectly fine. Now, an example of a generic type is a list that I'll show you right now. If I go list, we can see that this generic type right here has, as you can see, it says class system.generics list, and it has that T. This T in angle brackets is where we supply what type that this list is going to hold. So if I go int, if I pass in an int to the generic parameter, I can go list int my list equals new list of int. So now I created this generic class that takes in integers. So if I go mylist.add, you can see that it's looking for an int item as a parameter. It automatically set int everywhere. So now I can add in a 5. So now this whole list is designed about integers, and I don't have to create a new one. If I didn't use generics, I'd have to create a list for integers, a list for strings, a list for doubles, and things like that. I could easily switch this to a string, and now when I call the add function, we can see now that it says string item instead of integer. So now I can pass in hello instead of an integer. So now my list is based around strings. So that's the basics of using generic types. When you're actually building generic types, it's really simple. You just use those angle brackets, and you can look at the textbook for this. I'm actually going to be making a advanced C# video on this soon. But there's also this concept of constraints with generic types that allow you, because any type can be passed in, it allows you to specify, only take classes that are structures, only take classes that are class, or only take types that are classes, only take classes that have default constructors, and so on. So you can supply, what generic types can be passed, or what types can be passed into a generic structure. Now, what are some benefits of using a generic structure or a generic type? And obviously, the main benefit is just what I showed you, is that, if your type is going to be taking in something, or if your type uses some kind of data type inside of it, rather than having to code multiple different versions of it for each specific data type, you could make it generic, and then you could pass in, when you're actually calling the actual class or whatever it is, you could pass in the type that you want then. So like we did here with strings and integers, we could pass in literally anything that we wanted to. So that's really the main benefit of using generic types. So I didn't really realize that most of this chapter was just me talking, and I was just talking about things, and that may be painful to listen to, and there is a bunch of code in here, but most of it is just understanding, because the code is showing you how to build these things, but that's not what it's really about. It's really about, understanding when I should use this and things like that. So that's what I try to talk about. The last two things in this this objective, are extension methods and overriding methods. And these are just basic. These are just other tools in our toolbox. Extension methods allow us to extend a existing class and add functions to it. So if we have a class called product, and it has, let's say, it has no functions, inside of a separate class, I could make an extension class that extends that and adds a function to it, even though it's not even in that existing class. So if I ever called that class, whatever I extended to, it would exist there. That's pretty much the basic idea behind extension methods. And overriding methods, this is a little bit hard to explain. It deals with inheritance, and I have a video dedicated to just this on inheritance in my fundamental videos. But pretty much overriding method allow us to define specific behaviors in derived classes. So if we have a base class, let's say we have a class called animal. Let's say this class animal has a method called make noise. If a class derives from animal, let's say we have dog that derives from animal, that dog class has that same function, make noise. But we can make it better because dogs bark. So if we want to specifically make the dog bark, we can override the make noise function, and instead of just making a generic noise, we can make it bark instead. So that's more specific. So we can override the capabilities of some kind of function inside of our subclasses to make them more unique and specific, rather than just being the generic make noise or whatever it is. Like I said, I have a video on this specifically in the inheritance fundamental videos. So that's it for this video. Sorry for most of it. Like I said, was just me talking, but for the most part, if you're up to this and you're taking this exam, you should know how to build all these types. It's mostly just about talking and when to use things and when to use other things. So yeah, there wasn't that much code involved in this. The next objective, which is objective 2.2, is going to cover consuming types, and that will cover boxing and unboxing, converting between different types, and using the dynamic keyword. So that's what we'll get into next in objective 2.2. I hope you guys like this video, and be sure to stay tuned for the next one. Thanks for watching.